Thanks. So originally we'd said the title of this talk was Everything Was Better with Bluetooth, but we just didn't want to give away the surprise about the badges. So just a bit of background, really. This is a Raspberry Pi. It's not the kind of thing that is on the badge. It's a single-board computer. It runs Linux. It's a really useful bit of kit. But it is a really, really complicated thing. It's running Linux, all the drivers, utilities, millions of lines of code, and billions of transistors. Not just the CPU, but the RAM, having sort of half a gig of RAM, having graphics, USB, all of that stuff. And it's almost a mobile phone class processor. And you get mobile phone kind of battery life out of it. So, you're talking a few days off a reasonable sized battery. But it's not useful for something like this, where you'd be having to heft around this huge lithium-ion pack with you. And a lot of you have probably seen something like this. This is an Arduino Uno. It is a little microcontroller board. The little grey chip there is a microcontroller. And these things are amazingly useful. They have significantly less memory and processing power available to them, but they can still be used in a huge variety of things. So you'll find like smart cards, pretty much anything with a little tactile button on it now. Bike lights, probably doorbells, your car key fob, and then things like your mobile phone will offload tasks to microcontrollers for certain things. Your keyboard in your PC may well have one, your digital watch will have one. You probably interact with almost 100 of these things on a daily basis, and you never realize you're doing it, because they're so simple. The surface area for interacting with them is so small that you can test them to death. And while they may not be bug-free, you can make sure that they're pretty good, and they work so well that you're never even aware that you're interacting with a computer. They're kind of what computers should be and what we strive for most of the time. So, looking at the general differences between like a normal desktop computer and something like a microcontroller. So I'm comparing this with like an ARM microcontroller, which is decidedly mid-range. You can go down to micros with, I think, as low as 16 bytes of RAM. So a normal desktop computer would have like 1 billion times more memory. But yeah, so you're looking at like 1 million times more memory of both kind of non-volatile and RAM. But only really 1,000 times more processing power. So you've actually got 1,000 times more instructions per byte available to you. And it means that maybe you want to think differently about how you're writing code. So the Arduino, the blue board that you showed earlier, that had this chip on it, which is a AVR, it's called. It's made by Atmel. It's I think it's an 80 mega. The AVR architecture was made by some students at a company called Nordic Semiconductor in 1997, so it's 20 years old now. And Nordic Semiconductor have kind of been quite busy over the last 20 years. They've been doing a whole bunch of wireless chips. So for instance, if you own any wireless Logitech product, it probably has a Nordic chip in it. And recently they've moved on to doing Bluetooth stuff. So this chip on the right-hand side there is obviously much smaller. It's got an ARM core in it rather than an 8-bit AVR, so it's 32 bits. It's, I think, a 3 times higher clock speed, way more memory, and it's got Bluetooth built into it. And it turns out Nordic, they now sell, I think, half of all the Bluetooth low energy chips in the world. But this is Bluetooth low energy. It's not standard Bluetooth. It's kind of really misleading because it was introduced in Bluetooth 4. But it's like a completely separate thing. Different radio standard, but it just uses the same frequency and so the same aerial. But the nice thing is it's very simple to implement on a little microcontroller. I think the licensing's much easier on it, and it's a very low power thing, so you can run it off battery for ages. And really, this is all because this is what's on your badge. So you've got the LCD that obviously you've seen, the buttons. But the little blue thing on the side here with the tin can, that's an NRF52 chip. And you can see there's a little ceramic Bluetooth area on the top of it. It's also got NFC, which you can see on the back of it. There's like a little swirly aerial. And And we've brought out some other things where you can do capacitive sense, and you can solder some LEDs, and you can do like some nice prototyping stuff on there. So you probably noticed that, that you can press up and down and cycle through the pages, which is kind of a bit boring. You can also do this, which I think quite a few of you figured out last night, which unlocks the menu with like some extra functionality. Now, I wish I could say that I had swapped the buttons around intentionally to make it harder for you, but I didn't. I'm just useless. So yeah, this is not like a Game Boy. The buttons swap around. You get this menu, which is intentionally blurry because I wasn't sure it would stay the same. But you get a little Flappy Bird game you can play with on there. You get, for instance, a little Chrome T-Rex game. And you get the ability to design a screen for your badge in a sort of Etch-a-Sketch way, which my artwork, to say hello, definitely needs a bit of work on that. The other thing you can do, though, is you can enter a REPL, a full JavaScript REPL, where you can actually enter JavaScript code on your badge. Now, nothing's happening on here that's... it's not going up to a server to run your code or anything. It is actually executing JavaScript directly on your badge. So it's doing this using something called Espruino. And Espruino, it's an open source JavaScript interpreter for embedded devices. And it's designed to run on devices with really, really small amounts of memory. So down to around 8 kilobytes of RAM. So this thing's got 64, so it gives you a reasonable amount to play with. It does all the fun JavaScript things that you know about, and so actually you can run like most JavaScript code without having to worry. Your only problem is code size, really. And it does all this while drawing 0.5 milliamp. And to some of you that might not seem like much, some of you it might seem like a lot, but actually 97% of that is just driving this LCD display. The CPU's only drawing 12 microamps, so it's sort of 12 millionths of an amp all the time while it's just sitting here. So it really is virtually nothing at all. Espruino is also available on this little Bluetooth button called Puck.js, and on that, which doesn't have a display but uses basically the same module, you're looking at a year's battery life. Your badges should last around a week, although the more of the T-Rex game you play, the less it's likely to be. The weird thing is, though, that all of the stuff that was on there, the Flappy Bird game, the T-Rex game, the JavaScript REPL, including a little terminal emulator for it, the Etch-a-Sketch, and the 3 images that you cycle through up here, all of that fits into 20 kilobytes of unminified JavaScript code that's kind of human readable. And it's just kind of weird that JavaScript's so powerful that you can actually get so much in such a small space. So how do you use all of this stuff? Because the onboard apps aren't, they don't exercise half of it. Well, you could actually do it all by typing code into the REPL, but it would be extremely painful. But I would love to see what you can do using just the REPL. The real thing that you can do is you can use Bluetooth to actually get the REPL on your computer, and you can do this using WebBLE. So WebBLE is it's an API, I think originally made by Google, that it appears in the browser, and it lets you access Bluetooth low-energy devices directly at quite a low level. But it's a nice, easy API to use. Currently, it's supported in Chrome. It should be turned on by default. In Opera, I believe it's behind a flag. And there's pretty good support now for Android, Chrome OS, Mac OS, and Linux. Support on Windows isn't quite as good. Chrome doesn't support it out of the box. There's a polyfill you can install, but it's a bit of a faff trying to get it all working. iOS, Safari doesn't support it, but there is an app called WebBLE that implements it in a web view. So you can at least use kind of a pretty good subset of WebBLE on the iPhone if you need to. And hopefully over time these things will get better. I think there's reason to hope that Edge will have Web Bluetooth in at some point in the next year, possibly. And hopefully Google will get their act together and fill in the one platform that doesn't support it yet. So once you've done that, you can go to arduino.com/IDE and you get to a Web Bluetooth website, which is a complete little IDE for developing. So you've got the REPL, which would have been on here, but actually on the left-hand side of the screen there. And then on the right, you've got like a nice little syntax highlighted editor, and you can also switch over to a kind of graphical editor mode, which you just drag blocks around to choose what happens, and you can do some very limited stuff with that. For those of you that like command line stuff, there is currently a tool called Arduino on NPM, and you can get that, you can install it. You can also get the REPL, but you can then watch a file, and whenever that file changes, it'll re-upload it. So you can use whatever editor you're happier with. Your badge currently has a URL on. Some of you have probably tried this and found that it goes to a private GitHub repo. That should be made public around the end of this talk, I believe. And that contains a whole bunch of code and examples. The website at the bottom is live now, and that contains getting started and a load of other information. So the whole thing's open source. Arduino itself, the firmware is entirely open, the badge design's entirely open, all of the examples, the pre-flashed firmware, the tools, they're all open as well. So, so it's pretty much all on that website, which will go public soon. We've got a few other random things you can do. There's a little asteroids game. There's a really low-tech Mario game as well. And also, so a product that I make that is almost the same as this, but without the display and all the buttons, is Puck.js. It's just like a single little Bluetooth button. But there is a bunch of example code and tutorials on the Arduino website for that, and it should work almost identically on the badge. All you have to do to get connected to it is to unlock it with the Konami code, which was earlier and is documented on that site, and then go to make connectable. We haven't made them all connectable because it would just be mayhem in here, I think, when everyone figured out they could access everyone else's badge. On that website, there are a bunch of competitions. These are not things that there are prizes for. They're just fun things to do with the badge. There's a little bit of help about perhaps how you might get started with each one. But yeah, there's a bunch of fun stuff in there. There's also a grand challenge for which there is a prize. You can win a ticket to NodeConf next year. You can also, You can also run us up, get a few copies of this book, which is it's just kind of using JavaScript and the Arduino JavaScript interpreter to make fun hardware things. There will be a hacking station set up somewhere in the conference. I'm not entirely certain where, but it will have a whole bunch of stuff that you can solder onto your badge. So there'll be lights, there are a few extra buttons, I think there are sensors. And also, if you've accidentally blown away your badge firmware, we'll have a tool to put it back on. There's a workshop at 2 p.m. as well, where you can you can get started doing stuff with this badge. So what can you actually do with this? You've seen a few of the things that were pre-installed. Well, you've got the graphics library built in, which is obviously you can see being used with all this stuff. There's a simple variable called G that you can just do draw line, fill rect, draw string. You can draw images and stuff with it. You can do g.flip to swap the in-memory buffer over to the screen. So hopefully you do all the stuff you want, you swap it over, and you don't get any flickering. We haven't really mentioned Bluetooth other than to connect to this badge. So you can do physical web stuff with beacons. Once you upload the code for it, this will then start advertising either a unique ID or a URL. Most people's Android phones will automatically pick up the URLs from Eddystone stuff, which is a Google thing. If you've got an iPhone, you can sign up, you can get an Apple UUID, and you can do a similar thing with iBeacons. So you can use this to just broadcast whatever information you want. But it can also receive other badges broadcasts. So you can literally say, find devices, provide it with a callback, and it will provide you all this data as it comes in. So you've got like devices' addresses, devices' names, but if you have a device that's broadcasting this URL or a UUID, you can pick that up. And a really interesting thing is this RSSI. This is a signal strength. So you can actually see whether you are near or far from other devices. You can use it in a really simple way to just find the nearest device to you, or you can try and triangulate if you really want to work out a much better position. And obviously, if you have a few of them, you could start to work out actual locations of other beacons. You also have the ability to load in random extra JavaScript modules. These, unfortunately, they don't come off NPM because we've just found that the majority of the modules on NPM tend to pull in a lot of other modules, and you find out that you've used all of your 64K of available RAM before you've done anything. So all of these are actually coming off of a GitHub repository for things specifically for Espruino and for the badge. This particular one is for a keyboard. So when you flash the code onto your badge, you can then pair it with your computer or your phone, and it will appear as a keyboard or a sort of gamepad device. So you can use it to control stuff happening on your PC. You can use it to enter passwords for commonly used things if you want. So there's a lot you can do just by faking a keyboard. Obviously, there's mentioned WebBLE for actually connecting to it and programming it. But you can connect directly from whatever web page you want. There's a nice little library called Puck that abstracts basically all of this away from you, and you can just call it and issue a JavaScript command, and that JavaScript will be sent over to the badge and be executed on the badge. So either you can tell it to draw an image onto the screen, or you can actually ask it what's the temperature of the badge, for instance, or what buttons have been pressed, and it'll be able to respond, and you'll get a sort of JSON formatted response. So that's a really nice, easy way to use your existing stuff and just add a little bit more fun things to it. There are some examples on the website. One of them uses the Get User Media API so that it will use your webcam to take a picture of you, and then it will upload the picture of you to the badge. The other one will just take all the images that are currently off the badge off and will display them for you. But again, there's a whole bunch of stuff on the website to do with Puck.js and getting WebBLE working. You can also run WebBLE code on the badge itself. So this code here is it's actually connecting to a Bluetooth low energy light bulb. It's a totally standard light bulb available from Amazon. You just have these sort of two magic UUIDs for the specific thing for the value for turning the light on and off, and you write to it. But this, not only will it run on a website and turn the light bulb on and off, you just copy this code straight onto the badge and it will do exactly the same thing. So we'll have one of those at the hacking table you can play with. But there's a lot of other fun stuff you can control in a similar way. We have a little Bluetooth low energy parrot drone as well that you can control with this. There's NFC built onto the badge. It's as easy as just calling nrf.nfc URL and providing the URL. And then the next time you scan this, it will do that URL. So you can actually, while it's not a tag that is writable externally, you can write it from JavaScript code. So you can either choose what URL you want via a menu, or you could make it dependent on the temperature of the badge or any other external factor you want to. All of these things around the corner here, these are connected to the chip, so you can sense the capacitance of each corner. So what that means is that when you run this function, you will get a number back. If you happen to touch this, then that capacitance will go up by like a factor of 10 or more. So you'll be able to check that number and you'll be able to see whether it's been pressed. If you experiment with it, you can also see, like, almost depending how hard you press it as well, the value will change. So you can do that for all 6 corners. You can also control the voltage on each corner. These little things are big enough to get like a crocodile clip in or a banana plug, and I believe there are some wires and stuff at the hacking table where you'll be able to attach things to it. And much like standard Arduino code, you can just say digital write, give it a corner to use, or an LED that you can put into these little holes at the top, and you can turn them on and off and do fun things with it that way. You can also read the values back that are on them. So actually, I've got a bunch of time left. But so finally, I just wanted to say big thanks to Pimeroni, who have assembled all of these. They're a little company in Sheffield that does a whole load of fun Raspberry Pi stuff. And to Nearform for actually, this was like totally their idea and supporting the whole thing through the process. I only turned up yesterday with a bunch of badges. Before then, they had no idea they were actually going to arrive. So it must have been slightly stressful for them, I imagine. And yes, so all of this is based on Arduino. So if you like this stuff, check out the website, check out the other things that are also based on Arduino. It's not just the boards that are sold with this on, but because it's open source, it's available for a whole bunch of other stuff. So, for instance, the BBC microbit, which is this little device that is being given out to a bunch of kids in England. It's a sort of $10 learning tool. That also contains a Nordic chip. It's not quite as powerful as the one on here, but you can program that with the firmware. You can run JavaScript on that. There's something called the ESP8266, which is a amazingly cheap little Wi-Fi microcontroller. So this thing in quantity, it will cost sort of $2 to $3. You can pick one up on a little breakout board from eBay for sort of $5 to $10. And you can run JavaScript on this, and it's got APIs that they're designed to look exactly like Node.js APIs and behave in the same way. They're just not quite as full-featured. So things like HTTP servers and clients, currently UDP stuff as well. We've got WebSockets, MQTT, all kinds of cool stuff that you can play with. And all of this is like completely free, open, all available on GitHub. And that's it. I will be around like for the rest of the conference, most of the time at the hacking table. Obviously, there'll be the workshop at 2 p.m. But yeah, if you have any questions at all, or you've destroyed your badge software and want it reflashed, come and chat, and yeah, I'd be happy to talk. Thanks.